Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and I'm here with Victor to dive into the fascinating world of peer-to-peer technologies. Before we begin, I'd like to remind our listeners to rate our podcast on whatever platform you're tuning in from. Your feedback helps us grow and improve.
That's right, Sheila. Today we're continuing our journey through Season 2, where we're exploring core hole-punch technologies. We're in Chapter 2, focusing on Hyperswarm networking, and specifically we'll be discussing Hyperswarm architecture and concepts.
Excellent, Victor. To kick things off, I have a quiz question for our listeners. Here it is. In a traditional client-server model, how many central points of failure are there, and how does this compare to a peer-to-peer network like Hyperswarm?
Oh, that's an intriguing question, Sheila. It really gets to the heart of why peer-to-peer networks are so fascinating. It makes you think about the fundamental differences in network architecture and how they impact reliability and scalability. I'm curious to see how our listeners will approach this.
Indeed. Now, before we dive deeper, let's clarify some key terms. Victor, could you briefly explain what we mean by peer-to-peer and Hyperswarm for our listeners who might be new to these concepts?
Certainly. Peer-to-peer, or P2P, refers to a network where all participants, or peers, have equal status. Unlike traditional client-server models, each peer can act as both a client and a server. Now, Hyperswarm is a specific peer-to-peer networking solution developed by the hole-punch team. It's designed to make it easier for developers to create decentralized applications by handling complex networking tasks.
That's a great explanation, Victor. So, could you give us an overview of Hyperswarm's architecture? How does it differ from other P2P networks?
Absolutely. Hyperswarm's architecture is built around the concept of a distributed hash table, or DHT. Think of the DHT as a massive, decentralized phone book. Instead of storing names and phone numbers, it stores information about peers and how to connect to them. This allows Hyperswarm to efficiently manage peer discovery and connections without relying on central servers.
That's fascinating. If I understand correctly, it's like each peer holds a piece of this phone book, and together they form a complete directory. Is that right?
That's a great analogy, Sheila. You're absolutely right. Each peer in the network maintains a portion of the DHT, and when a peer needs to find information, it can query other peers to locate the data it needs. This distributed approach is what makes Hyperswarm resilient and scalable.
I see. So how does Hyperswarm use this DHT for actual networking? It can't just be about storing peer information, right?
Excellent question. This is where Hyperswarm's concept of topic-based networking comes into play. Instead of connecting directly to known IP addresses, peers in Hyperswarm connect to topics. You can think of a topic as a virtual meeting point or a chat room. When a peer wants to join a particular swarm or find other peers interested in the same thing, it announces itself under a specific topic in the DHT.
Oh, that's interesting. So it's almost like a decentralized version of interest-based social media groups?
That's a great way to think about it, Sheila. Just like how people with similar interests gather in specific online groups, peers in Hyperswarm gather around specific topics. The key difference is that there's no central server managing these groups. It's all handled by the DHT and the peers themselves.
I think I'm starting to get it. But Victor, how does Hyperswarm actually establish and manage connections between peers? That sounds like it could be quite complex in a decentralized system.
You're right, it is complex, but Hyperswarm handles a lot of that complexity for developers. When a peer wants to connect to a topic, it announces itself to the DHT. Other peers interested in the same topic can then discover it and initiate a connection. Hyperswarm takes care of NAT traversal, which is the tricky process of establishing direct connections between peers that might be behind firewalls or routers.
That sounds really powerful. How does this compare to other P2P technologies like BitTorrent?
Great question. While both Hyperswarm and BitTorrent are P2P technologies, they serve different purposes. BitTorrent is primarily designed for file sharing, whereas Hyperswarm is a more general-purpose networking solution. Hyperswarm's topic-based approach makes it more flexible for building various types of decentralized applications, not just file-sharing systems.
I see. Are there any common misunderstandings or pitfalls that developers should be aware of when working with Hyperswarm?
Absolutely. One common misconception is that P2P systems like Hyperswarm are always faster or more efficient than centralized systems. While they can be more resilient and scalable, they also come with their own challenges. For example, peer discovery and connection establishment can take time, especially in smaller networks. It's important for developers to design their applications with these characteristics in mind.
That's really helpful, Victor. As we wrap up, could you share a fun fact or interesting anecdote about Hyperswarm?
Sure. Here's an interesting tidbit. The name Hyperswarm isn't just a cool-sounding term, it's actually quite descriptive of how the system works. In nature, a swarm is a self-organizing group of individuals, like a swarm of bees. Similarly, Hyperswarm creates self-organizing networks of peers. The hyper part refers to its ability to create multiple, interconnected swarms based on different topics. It's a great example of technology mimicking patterns found in nature.
That's fascinating, Victor. Now let's reveal the answer to our quiz question. In a traditional client-server model, there's typically one central point of failure, the server. If it goes down, the entire system is affected. In contrast, a peer-to-peer network like Hyperswarm has no single point of failure. Even if several peers go offline, the network can continue to function.
Exactly right, Sheila. This resilience is one of the key advantages of peer-to-peer systems like Hyperswarm.
To summarize what we've learned today, Hyperswarm is a peer-to-peer networking solution that uses a distributed hash table for peer discovery and topic-based networking for connections. It handles complex tasks like neat traversal, making it easier for developers to build decentralized applications. While it offers advantages like resilience and scalability, it's important to understand its unique characteristics when designing applications.
That's a great summary, Sheila. I hope our listeners found this deep dive into Hyperswarm architecture and concepts informative and engaging.
Thank you, Victor, and thank you to all our listeners. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy coding.